Today we are going to explore the solar system with our very own telescope. Now, Nee and I are here on our roof in the middle of our busy city, and we are going to watch space. Man, look out there. Look at all that. Oh, Nee, it's a helicopter. Whoa, man, it's too much light. The helicopter went away. Cool. Now,
God, can this fog get out of the way?
we got fog and helicopters?
We can't see the stars.
I know, it's so frustrating, but maybe there is something else that we can do. I've got an idea.
I've got an idea too.
All right, well,
What's the Mario?
It does look like Mario, but it's not just a flower pot, Nee.
Okay.
Now, we are gonna try to get our telescope up above the helicopters and the fog. Shall we?
Fly telescope.
Now look at it go up, Nee. It's going up, 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 up.
Oh, the birds caught the balloons.
It's flying!
That was bad.
That was really bad. I think it might have hit a car.
Oh no.
Sorry, everyone.
Let's discover some different types of telescopes.
Let's discover some different types of telescopes. I agree. Now, this is our first type of telescope.
Ground-based telescopes. They stay on the ground. Some use lenses, refracting. Some use mirrors, reflecting. They help us see stars, planets, and the moon.
Yeah, there are all types of ground-based telescopes. They use lenses and mirrors, and some of them actually catch radio waves too, like this giant disc that you see here. That's a radio telescope. But they help us see stars, planets, and the moon. Now, this is the second type of telescope. These are mountaintop telescopes. They're a special category of ground-based telescope. They are put on top of tall mountains. Now, why would you want one on a telescope on top of a tall mountain?
The air is cleaner up there. That helps telescopes see space more clearly.
Yeah, when you don't have a lot of clouds and stuff, you can see space more clearly. Now, this is the type of telescope that we are trying to make. This is number 3.
Balloon telescope. These are tied to big balloons that float high in the sky. They go above clouds to see better. They are cheaper than space rockets. They are used to try new ideas, look at the heat from the space, and do science experiments.
They are used to do lots of things. Now, I'm going to tell you about the 4th type of telescope. These are space telescopes. They go around Earth, like Hubble or James Webb, and they travel deeper into space. They can see light our air blocks, like heat, which is infrared, UV, X-ray, and gamma rays. And they give very clear pictures because there's no air in the web.
Yeah. Airborne telescopes. They're put on airplanes like Sophia. They fly high above the clouds where there is a little water vapor, so they can see heat from space, infrared light, more clearly.
Yeah, infrared is going to be heat type of light, and they can see things more clearly. Now, let's look at this final one. This one is so cool. It's underground or underwater telescopes. So sleepy. These are not normal telescopes for light. They are special detectors that find tiny space particles called neutrinos. An example would be Ice Cube in the Antarctic and the Antares, which is under the Caribbean Sea. Pretty cool. Now, we're going to talk to Erika today, who actually built telescopes. Now, Ailani, can you ask Erika her first question?
Did you ever want to see more stars when you were little?
Yeah, when I was little, I grew up in New Jersey, and my mom used to tell me about when she grew up in New Jersey and there was like a huge blackout in New York City in like the 70s. She like went outside and like looked up and was like, oh my God, there's so many stars. And she didn't know what it was actually. The first time that I experienced that was like actually observing when I was in college, coming to Arizona and going to a telescope. And then I remember going outside and being like, oh my God. And actually it used to be that you could see the Milky Way every day wherever you were on Earth. It was a normal thing, and now you can only see it if you like go to these really dark locations, but actually we should be able to see it all the time.
Now, Erika has a question for Ailani.
Okay, Ailani, so do you know what part of the universe we live in? Our address.
Milky Way.
Boom. The solar system, which is inside the Milky Way. So you nailed it, Nee. Good job.
Dad, our telescope is broken.
I know, it keeps sending us all these weird fuzzy images. I mean, this was before it fell down and broke on the street. But I don't know what we're looking at. I wonder if there's someone who can help us fix this.
What happened when your telescope had problems in space?
So this is a project that I've been working on for a while called Fireball. That is a telescope that goes on a balloon, much bigger than like a party balloon. It's a 40 million cubic foot volume balloon. So it's like the size of a football field. And we've launched it twice in 2018 and then in 2023. And actually both times the balloon had a hole in it. Yeah, like extremely unlucky. There's like a 5% chance that the balloon has a hole for a couple of different reasons. Whatever the opposite of lucked out is, we really unlucked out. And so we've actually like paused the project and we're trying to figure out a better way to do the observations. I have some other projects to kind of do similar observations of trying to understand how galaxies form and like the material that's around them. And so basically after it didn't work, we are kind of regrouping and thinking about like what's another way to still get the data, but just maybe not with a really giant fragile balloon.
Whoa, balloon had holes? That is a big problem. Now, Erika's got a question for Ailani.
Do you know the name of the star closest to Earth, the best star?
Sun.
That's right. The sun is a... Whoa. Look at that sun, man. It's pretty rad. The sun is
Fire.
actually a giant exploding nuclear reaction. A nuclear fission reaction, actually. Pretty cool. It looks all cute and warm, but it would burn you to pieces.
Like if you even got one tiny step close to the surface,
Not good.
like
Now, Nee, we need to fix our telescope. What do you think we need to do? I first of all think these balloons maybe are not the
let's
best.
take that off.
Yeah, we need to get some new balloons. Now, but I actually don't know.
What's wrong with our balloon? Let's learn more from Erika.
Yeah,
What do you look for in space with your telescope?
yeah. What does Erika look for in space?
So what I'm interested in is figuring out how things form. So like if you look out at night, you see a lot of stars, like little points of light. You can see planets, you can see the moon. Actually, if you're in the northern hemisphere, you can see the Andromeda galaxy. If you're in the southern hemisphere, different times of the year, you can see the large and small Magellanic Clouds. And so each of Andromeda and the large and small Magellanic Clouds are actually their own galaxies. And so I like looking at galaxies, I like looking at stars, but I'm really interested in how they formed and like how do they survive. So our galaxy exists in kind of a bigger, what we call a halo that's like around the galaxy that consists of dark matter and also like hydrogen from the Big Bang and also from our galaxy and from galaxies that our galaxy has eaten. And it's this like kind of messy environment that we think is important for our galaxy to keep making stars. So the telescopes that I build are really interested in looking at like not the galaxy itself, but the stuff that's around the galaxy and not really the stars themselves, but like the places where the stars form out of mostly hydrogen. I'm like weirdly interested in the precursor thing. Like, I like a galaxy. I'm happy that we live in a galaxy, but I also am really interested in like the material that kind of goes into things and not the thing itself.
Erika has a great question for Ailani now.
What do you think makes stars shine so brightly?
I think the gases around the star.
Right? Maybe it is. They're actually a giant exploding reaction in space, and they burn hydrogen and helium gas. Now, really quickly, we need to learn about the life cycle of stars. A star begins in the stellar nursery,
Stars begin in giant clouds of gas,
and dust called nebulae.
nebulae. Gravity pulls the gas together.
And it gets hot as a new star begins to form. And then we get the next step, which is
Protostar.
yeah, as the gas comes together, it makes a small, hot center, like this. She's getting hot. Whoa, she just turned into a star. This baby star glows a little from its heat.
But nuclear fusion hasn't started yet.
It's right, nuclear fusion hasn't started yet. But when it does, we enter the main sequence of our star.
When the star starts shaking hydrogen into helium, it becomes steady and bright. Our sun is in this state. Stars can stay like this for a very long time, millions or even billions of years.
Billions of years. Now, when the star starts getting older, it can turn into a couple different types of things. One is a red giant or supergiant. When the star uses up its hydrogen, the center gets smaller and the outside gets bigger. Small stars turn into red giants, and big stars become supergiants. Now, there can be two ways that the star ends, and it depends on,
Mass.
low-medium stars like the sun.
The outer inner parts of the star float away into space, making a pretty cloud called a planetary nebula.
Now remember, a nebula is also where stars are born from too.
The center that's left becomes a white dwarf, which cools down slowly.
And that's the inner cooling part of the star. Star. Now, for massive stars, they collapse violently in a supernova explosion. The core becomes either a neutron star, or if massive enough, a
Black hole.
That's right. Now, Ailani and I have a new prototype telescope. Let's give it a test.
Oh, Dad, it's not working right.
I know, we just sent it up into space and it's still not working. There's one person that we can ask for questions. Ask Erika.
What is that foggy glow around the galaxies?
What is that foggy glow around the galaxies?
So that's like kind of the stuff that I'm looking for, is like this material that we think is there. We've looked at like really distant galaxies, and for those distant galaxies, we see this like halo material around it or near it. But then if we want to look at galaxies that are close to us, like when we look at distant galaxies, we're looking into the past. And so we could see that in the distant past, galaxies all had this material, but we don't know about galaxies that are like how they exist right now, nearby galaxies. That's kind of the observation that I want to do. You can get like hints that the stuff is there, but it's not really a useful measurement. The type of measurement that I want to do is in the ultraviolet. It's like a lot more difficult, and that's why we don't have like exact pictures of these halos, but hopefully in a few years we will.
Now, Erika has another great question for Nate.
Do you know what galaxies are made of?
Stars, gas, dust, and planets.
That's right. Is that gas? Like, is it like the planet's burning right there? Our telescope couldn't see that glow, but Erika's could. Her telescope sees ultraviolet light.
That's pretty cool. What is ultraviolet light, and why can we see it?
This is a great question.
So ultraviolet light is a type of light. There's like many different wavelengths of light. Our eyes are designed to observe in visible wavelengths because that's the part of the spectrum where the sun puts out the most photons. So like we evolved to take advantage of where all the photons were. And ultraviolet light is a little more energetic than visible light. And it's actually the type of light that gives you a sunburn. If you like go out without sunscreen, the UV light will get absorbed by like the top layers of your skin. And then it has just enough energy to cause like DNA damage and problems and whatever. Whereas if you go to even a higher energy, that's like X-rays. X-rays are really energetic and they can pass all the way through you, which is why you can use them to take pictures of your bones or your teeth. And then even higher energy is gamma rays, which is put out by nuclear reactors. And it's like super dangerous that it goes right through you, but also it like messes you up on the way. So the UV is kind of the least energetic, but still dangerous type of light. Luckily for us, most ultraviolet light, all X-rays, all gamma rays are blocked by the Earth's atmosphere. So we're protected from most of those photons, except for a few parts of the UV. The UV is kind of a strange wavelength range to work in because it doesn't have the same kind of broad applications that like X-ray technology has. You want X-ray detectors for medical stuff. You have X-ray optics for like a bunch of things, or even like infrared, which is on the other side of the visible light. Infrared is like thermal energy. That's useful for like night vision and all sorts of stuff. So the UV is kind of in this weird space where there aren't a lot of commercial applications, which has made it hard to do astronomy. Like one of the things that I had to do as a grad student is help invent the detectors that we now use because there wasn't like an existing good detector. So it just makes things a little harder.
And now Erika has a question for Nate.
What kind of light can we see with our eyes?
Visible light.
Yeah, visible light.
Our balloon is up in space and it is looking at so many different things high above the planet. Now, Ailani, can you ask Erika this question?
Why do your telescopes go on balloons instead of staying on the ground?
For life on Earth and like us here, it's great that the atmosphere blocks the ultraviolet because it would kill us all. And actually, it's mostly oxygen molecules and ozone that does most of the absorption. If we had the telescope on the ground, you're really limited in the types of photons that you can measure. But if you put your telescope in space, then you don't have to worry about the atmosphere. And so for ultraviolet telescopes, we want to put them above the atmosphere, or in the case of the telescope that was on the balloon, you put it above like a large fraction of the oxygen. And that's pretty common too. Like the reason that NASA puts telescopes in space is like the James Webb telescope is looking in the infrared, and it's looking particularly at parts of the spectrum that also get absorbed by the atmosphere. So you have to like go above the atmosphere in order to even just like see anything.
Now, it's great information. Like if you're above the atmosphere, then you can see more things. Erika has a question for Ailani.
Why do you think we need to go above the clouds to look at space?
The atmosphere blocks UV light.
The atmosphere does block UV light. Now, Erika told us the wildest story. One day, a falcon landed on her telescope.
Is it really true that falcon landed on your telescope?
Right?
It is true. It was like the cutest, most angry little baby falcon. He was so cute. I don't even know if it was a he or she. We put him in a box at the airport and he was really upset, like scared, I think. And actually some of the people on our team, they were like, oh, we should give him water. Like, what about worms? And I was like, I don't think that he wants to eat anything from us. And they were like, no, we're getting worms. And they went to like the bait shop in the town and then came back with worms and they like, put it in the box with him. There was like a live worm and then a different worm that they like cut up. But his parents were around, and I think it's normal for that type of falcon. They're learning how to fly, so they like fall out of the nest and they kind of like swoop around, but they're not like coherent. He was gone a couple hours later, and the next day we saw him like flying around the parking lot, and he was fine. And he didn't eat the worms in the end.
Now, Erika has a question for Ailani.
What do you think that the falcon thought that it was landing on?
Maybe like a tree or a rock.
Maybe. Actually, now boys and girls, just because you're not a scientist now doesn't mean you can't be. Now, Erika, before she was in science, she was a real chef.
Wow. Erika, make me some food.
Now, Ailani has a question for Erika. Not make you some food.
How did you go from cooking to studying space?
How'd you go from cooking food to studying space? Because that sounds like an awesome transition to me.
So before I went to grad school, I went to cooking school and I worked in a restaurant in New Jersey for like 6 months. And I knew when I was in college that I really liked space, but I also really liked food and like eating and cooking food. I had been in grade school and then I had been in university for 4 years. And then I was going to do graduate school and that was going to also be like a really long amount of time. I didn't want to be at a university continuously for like 11 years in a row. And so I thought, okay, I'll take a year and do this other thing that I know that I like. And then I can decide if I want to go back to astronomy or if I want to stay cooking and like have a restaurant. After a couple months working at the restaurant, like the restaurant was really good and the chef was really good and like we had great customers. Once I learned the menu, I felt like it wasn't as interesting and like I wanted it to be different every day. It was nice to like create something like you're chopping. You make like a physical object, which was really nice, but then intellectually it wasn't as interesting as I think I wanted. So then I knew I'd go back to grad school and then keep on the path of being an astronomer. Even in my work as an astronomer, like I still like to create things. Part of why I like building the telescopes is because you like make a physical thing and it's something you can like touch and use. It's just much more pleasant for me to do the lab work and like the physical work than just doing data analysis on a computer or like simulations. I don't find that as satisfying. So some of the parts that appeal to me still are valid.
Now, Erika has a great question for Ailani.
What recipe do scientists follow when solving big problems?
We learned about this on our video with Maynard. What do scientists use to study the universe?
The scientific method.
That's right. Now, with Erika's help, we fixed our telescope and now we're ready to see everything. Now, Ailani, can you ask Erika this question?
What advice do you have for kids who want to build or explore things too?
The best advice I can give is that you should figure out what you like doing. Sometimes I talk to my students, I use a phrase that I know is cheesy, but the only way to describe it is like, what is in your heart of hearts? Like, deep down that you don't want to tell anybody about or that you're anxious about. Think about what do you really love, honestly, and like vulnerably. Once you figure that out, you have a direction and then you can be like, okay, now I like building telescopes, so that's all that I'm going to work on doing. And then it's mostly just ignoring people that tell you to do something different and to be really certain of yourself. If you know that that's what you want, then that's the only thing that matters. People tell you like, oh, you have to do things a certain way or you have to do this or not do this. That's all advice. And some of it is useful, but a lot of it isn't, and you can figure out your own way to get to something that you really care about. But the important thing I think is like figuring out what you really love and doing work because you love it and not because like someone else told you to do it.
Now, Ailani, here's one last question for you from Erika.
How many planets are in our solar system and which one should we look at first?
8 planets. And I think I want to look at Venus because it's flaming hot.
I want to look at Jupiter because it has a giant storm that looks like a giant red spot. But you know what, guys? There's no right answer. Whatever planet you want to look at, it's a good answer. But let's see if you can remember the planets in order. Me? Mercury.
Smallest planets, no M's. Me.
Venus.
Hottest planet, thick atmosphere.
Earth. The
Only planet known to support life.
Mars.
Our planet, tallest volcano.
Jupiter.
Giant storm, many moons.
Saturn.
Beautiful rings, has a giant
Gas giant and low density. Yeah. Uranus.
Tilt sideways, pale blue color.
Neptune.
Farthest planet, fast wind.
Hold on. I see you right there, Pluto. We remember you. Shout out to Pluto. Love you, Pluto. It used to be a planet, but they've made it down into a mini planet now. Come on, man. Pluto deserves love too. We saw stars like never before. We saw galaxies and their glowing fog. It felt like magic.
Yeah, we could see the stars from the city, but now we can see the whole universe.
That's right, because we listened to Erika. Now, Erika's final question for Ailani.
What's the very first thing you want to look for in the universe?
Other galaxies, like universes.
I like that.
I want to see if there's alien life out there.
I agree. I think that would be really interesting. If the stars feel far away, build your own way to reach them. You never know what you'll discover. We hope you guys have fun, and from me and Ailani and Erika,
Bye!
we'll see you guys next time.